Hello and happy Monday. Today we are going to start a new unit, Unit 5. I know we missed one unit, so don't worry about that. We're just going to continue on um, with the course and kind of focus on the stuff that's most important, especially for those students going to grade 12. So Unit 5 is going to be on sine functions. This is pretty new to you. Don't panic, don't stress out. There's going to be some new terminology, but we will go slow and we will get through it together. Some of it will be a repetition of what we did in Unit 2. So it's not going to be completely new, but you will see some new terms that you might not have seen before. So like I said, it's going to be on sine functions. And yes, this does come from, kind of comes from SOHCAHTOA, where we're going to be graphing sine x as a function, so as a graph. And this is actually what it'll look like, and we will get into that, not quite today, but in the near future. So today we're going to be looking specifically at periodic functions, but the sine function is within periodic functions. So we do see periodic functions in real life. These graphs and these equations will be used to model some of these things, and they can be really important. So some of the things where we would see it are ocean tides and how they change. So you know that an ocean tide comes up. Seasonal changes in temperature, the sun rising and setting. So these are things that happen again and again and again, and they'll continue. They repeat, all right? Some rotating objects like a Ferris wheel, bike wheel, pendulum, or something like a heartbeat. So just to kind of show you a little illustration, we have this triangle that's being made around the circle. And what this actually does is it does graph a sine function. If we were to take its height and go around, it does create that graph. So don't worry too much about the details of it. We will get to it, but just to show you. We also have this sine wave that's going to be produced by a bouncing spring. So it's the location of, I guess, the ball in the end of the spring, and it's something that just goes up, comes down, up, down, up, down, and it just repeats itself. So that really is what a periodic function is. And we will get into the specific sine function very shortly. But today we'll just focus on the periodic functions. So hopefully you are able to print this. If not, that's fine. You can just label everything 1A, B, whatever. And if you're doing your homework, or when you're doing your homework online paper, make sure you number it and put the pages for me. So a periodic function is a function that repeats a pattern or a cycle. That's what we might call it as well, at regular intervals. So it might be every 3 seconds or every 5 meters, depending on what the parts of it are. So again, we're going to see lots of new words. You'll hear them a lot, so don't worry about them, but they will be new for you today. And if not, that's great. So period is one of the new words we're going to look at. It is the horizontal distance from the beginning of one cycle to the end of that cycle. So if we look here, we want to look at the part that's repeating itself. So here we have like the top of the V, and here is another like upside down V. So this here is one cycle, and the distance from here to here is the period. All right. Now we don't say that this is a cycle because yeah, this is an upside down shape, but it's not a V, so that's not where it repeats. And obviously it is possible that we just have something that isn't periodic, doesn't repeat itself, and we wouldn't be measuring the period or the amplitude. Okay, so it is a distance from the start of a cycle to the end of it. So what we could do is just subtract 16 minus 6, and that would give us the period. So in this case, our period is 10. Whatever units those are, it doesn't specify. So another keyword, another new word that we will see a lot is the amplitude. So instead of it going horizontally, the amplitude goes vertically, and it is half the distance or half the difference between the maximum value and the minimum value. So, sorry, we find the highest point and the lowest point, which might be here, and we divide that distance in half or in two so that we get what we call the amplitude. So period goes horizontally and amplitude goes vertically. All right, so we're going to do some of these examples together. First, we need to determine if it is periodic. So does it repeat itself? Okay, and we're going to use that based on the information we see. Obviously, the graph continues and we don't know what's there, so we're just going to look at what we see. If it's periodic, we will determine the period, amplitude, and domain and range of each of these functions. So first, we're going to look at this one. Is it periodic? Well, yes, this is periodic. So we'll say periodic because it repeats itself. Okay, so since we see that it starts here, goes down, comes up here, and it's going back in the same direction, we can just make this assumption that it's going to repeat forever. But again, we can only base our information on what we see. So yes, it's periodic. Now we want to find the period. Okay, so the period is the distance between the beginning and the end of a cycle. So here, I can calculate the period from here. If I say that this is the beginning and this is the end, I could also do it from those 2 points. That could be the beginning and the end. It repeats itself, so it doesn't really matter which one is, what point is the beginning and the end, but the distance will be the same. So what we're looking for the period is this distance. Well, we can kind of just count, especially in this one. This is a 5, this is a 1. So what we do in order to find the period is we subtract 5 minus 1, so our period is 4. 4 units, we don't know what x represents. So the amplitude is going to be done similarly, but we know it's half. So what we have to do, instead of reading down to the x-axis for the period, we're going to read over to the y-axis for the amplitude. So what we want is the highest point and the lowest point, 3 and -1. So for the amplitude, we are going to subtract them, 3 minus, and be careful, we're subtracting -1, and we're going to divide that by 2. So our amplitude is 3 plus 1 over 2 is equal to 4 over 2, which is equal to 2. So our amplitude is 2. Okay, the key thing here is we're going to divide it by 2. And finally, we need our domain and range. So domain and range is the same way we did it before. Let's squeeze it over here. D is for domain, and domain represents all of the x coordinates that are taken by the graph. Since this continues, but we can tell by these arrows, forever and ever, both ways, left and right, we just say we have XER. Okay, XER will be common. X is a member of the reals, unless it specifically says that it does stop. So our range is going to be a little bit different, but here, if we have a periodic function, our range is just between the highest and the lowest value. So we always start with YER for the range, and we put a Y in the middle, put our little less than or equal to, put the smallest number in front, -1, the largest Y value in the end, 3, and that's it. So our range is that Y is a member of the reals such that Y is between -1 and 3. Okay, so this one here, is it periodic? From what I can see, no, because nothing's repeating. So here we have this, and if that continued, it would be periodic, but it doesn't. This goes here, so we can say this is not periodic. Okay. The last one we have, we need to identify if it is periodic or not. Do we see a repeating pattern? Well, I can see one here. We have, this is our highest point, and if we go across, we can continue to see that. If this was to continue, we would expect it to, whatever, do that, and go on and on. Okay, so we can say, yes, it's periodic. Okay, it repeats, it continues over and over again. So now we want our period. Okay, so what we can do here is try and identify the start and the finish, and it can be any point. So what we can say is, let's say this is our starting point and this is our ending point of the cycle. So our period is just a distance between those 2 points. So this one is it doesn't fall on whole numbers, but if we go down here, we can say that this is maybe negative 3.25. And this one here, if we read it down, we get -1. But if we actually, let's see if we can find one that lies on whole numbers. We could choose different start and end points so that we have whole numbers. For example, if we chose -1 and -4, okay? That gives us the same period, but they're easier numbers to work with, so we can do that. So when we do the period, we subtract the two points we've chosen, so we can do -1 minus -4. Okay, those become a plus. So we have -1 plus 4, which gives us a period of 3. And just remember, period is a distance, so it always has to be positive. Okay, so period, it's a distance, so it must be positive. All right, now our amplitude, we are going to take our highest and lowest point. So if we look here, we want to take our highest point, which this looks to be about 1.5. Our lowest point, -1.5. So our amplitude is, we subtract those, we have 1.5 minus -1.5, and we have to divide it by 2. Those two negatives make a positive. So what we get is 3/2, which if we can leave it like that, or we can say that our amplitude is 1.5 if we divide. Okay, so our amplitude is 1.5. And finally, we need our domain and range. So our domain is XER. Okay, it continues forever and ever left and right. And our range is always going to start YER, such that put our y in the middle, less than or equal to smallest number, 1.5, our lowest number, and our highest. Okay, and that's our range. Okay, so that's all we have for this page. All right, on the back page, this is going to be a little bit of a review. Nothing here is going to be completely new. Yeah, so this one here, it says that this is a periodic function. We can see it repeating. We don't know the details of the equation or the function exactly, but from the graph, we want to find the value of f at 0. So remember, when we have this is saying f at 0. And when I say f at 0, I'm meaning what is the y? I'm going to write this. What is the y when the x value is 0? Okay, so that's what it is in words. So if you want to say it f at 0, not fat 0, f at 0, and in words it's saying what is the y when the x value is 0. So let's find our x value of 0 here, read up to the y. So what we say is f at 0 is equal to 2. Determine two other values of x that give the same value of f. So what we want f at something equal to 2, and another one where f at something is equal to 2. So what we have to do is find out other y values equal to 2. Well, we have this one, so we can say f at -2 is equal to 2. And we have this one, which is f at 2 is equal to 2. Okay, if you have any questions about this, if you don't remember, please let me know, because it will come in handy in future lessons. Okay, so we're going to do the same for f at 0.5. So what is the y value when x equals 0.5? Well, 0.5 is here, and our y value is 0. So f at 0.5 is equal to 0. Determine two other values of x that give the same value of f. Well, we can just like read across. All of these are options. So we can say f at -3 equals 0 for this one. We can also say that f at +3 is 0. So we get this one. All right. And the domain and range. So our domain, since it repeats, it's going to go on forever and ever, left and right. Our domain is just XER. X is a member of the reals. It contains all X values. And range is going to be YER. Range will never be just YER because it has to go up and come down. So it does have a maximum and it does have a minimum for it to be periodic. So Y is between our highest point and our lowest point, -2 and 2. Okay, so this one here, it is asking us to just graph this data. The table shows the number of daylight hours in Hamilton on the 1st of each month for 1 year. First, create a scatter plot. So I'm going to set this up and then I'll just plot it. I'll pause the video so you don't have to listen to me plotting it. But it's up to you how you make the axes. For the x-axis, you will have the months. So you have January, February, March, April, May, June, July, August, September, October, November, December. So obviously this is our months. And our hours of daylight, what I found to be best was to make a little break in the graph and start at 9. So 9, 10, 11, 12, 13, 14, 15, and 16. So give this a try on your own. I'm going to pause the video so you don't have to follow along with. All right, so here I have plotted the data. So we see this increase, which is something you would expect. It obviously we get more daylight hours in the summer and less in the winter months. So does this represent a periodic function? Well, looking at it here, if we didn't have any context, I would say, well, we don't really have enough information. It doesn't repeat itself on the graph. But since this is something that would repeat every year, let's say we have this graph, which is 2020. Well, what's going to happen next year? If this is December, the next month is going to be January. So it's going to happen again. Okay, this is 2021. Then it'll happen again. 2022. So really, yes, this would be a periodic function because the data would repeat itself the next year. So we really do need the context here. Otherwise, I would say no. But since we know it's a yearly thing, obviously the next month after December would be January of the next year. And what are the maximum and minimum number of hours of daylight? Well, that's pretty easy. We can look at the chart. So max is 15.3 hours in July. And the min is 9.1 hours in January. Okay, so that is all for today. There is some homework questions. Please let me know if you have any questions so I can help you out. And again, don't worry about all the new terminology. We will be using it over and over, so you will get used to it. All right, enjoy your day.